Move on to a quick review of the periodic table. Right, so remember that the atomic number is equal to the number of protons, and it's written above each symbol on most periodic tables, right? So hydrogen, 1 proton, helium, 2 protons, lithium, 3 protons, beryllium, 4 protons, boron, 5, carbon, 6, nitrogen, 7, oxygen, 8, fluorine, 9, neon, 10, and on and on and on. We have metals on the periodic table. Metals are malleable, ductile, and they have luster, meaning they're shiny. Most of the elements that exist are metals, right? And that means that they exist as cations in a sea of electrons, if you remember that from Chem, which accounts for their excellent conductive properties. They also form oxides, which means they tarnish, they rust. Oh my gosh, I'm not even on the screen. I'm sorry. They tarnish, right? That is rusting, right? You guys have heard that the name of rust. Common rust is iron oxide. So this rust is an oxide of iron, right? So we have iron, and then it reacts with oxygen to create some combination of that, right? I'm not going to bother balancing that because it's not important, but we have an oxide of iron, right? This is rust. They will readily they will form positive ions, aka cations, like we introduced last video, I believe it was. Now, you might have noticed that a lot of these metals, they have weird symbols, right? So a couple of examples of metals that have weird symbols. Antimony, right, is symbolized by SB. That's because the original name, which is usually Latin, okay, not always, but usually Latin, is stibium. Copper is not CO. It's not. It's Cu, because the original name was cuprum. Iron is Fe because the original name was not iron. It was ferrum. Lead is Pb because it was originally plumbum. And we see that these names that we use here in English are not the original names. The symbols that are associated with each of these metals are based on their original names. So we have a couple different organizational strategies on the periodic table. We can organize elements in groups or families. These are the vertical columns, meaning they go up and down. Elements that are in the same group or family have similar physical and chemical properties, because remember, bonding is based on electrons. And all the elements in the same group or family are going to have a similar electron configuration. So if they have similar electron configurations, they're going to have similar chemical activities. So we have group A, right? So you got 1A, 2A, 3A, 4A, 5A, 6A, 7A, then 8A. So any of the A's. These are called representative elements. Right? In Gen Chem, I use the term main group elements. Right? These are also known as representative elements. But then there are the group B elements down here. Right? So I got 3B, 4B, 5B, 6B, and on and on and on. These are the B group elements. Group B is the transition elements. They're all metals. Right? They have numerous oxidation or valence states, meaning they can form different charges. Right? They can form different charges. Right? Okay, iron, for example, can form a +2 or a +3. I can form +2 or a +3 based on what orbitals are available within its electron configuration. But there's no way to know which charge an iron atom is going to form just by looking at the iron itself, right? They can form multiple. We can also organize the periodic table into periods. The periods are the horizontal rows, right? And just an aside, remember, going up and down, those are columns. Those are columns. Going left to right, right, horizontally, those are rows. And so when you're growing up in 3rd and 4th grade, well, and all the other grades before that, you talk about, your group being your row, and they'd think front to back, right, was your row. That's not a row. That's a column, right? Rows go side to side. They're horizontal. So periods will, because they go horizontally, starting on the left, going to the right, they will progress from metals to metalloids, and then they will get all the way to nonmetals, right? So we have metals transitioning into metalloids, and then nonmetals, right? Going left to right, left to right. So, what we want to memorize, okay, these are things that we want to memorize. Not necessarily because there's going to be a question directly asked about it, but because just having this information in our mind is going to make things so much more fluid as we go to try to problem solve for the things we're actually supposed to learn. So we want to memorize the alkali metals, right? Group 1A. Group 1A. So hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. We want to memorize the alkaline earth metals. That's 2A, right? And so depending on what periodic table you're going to look at, they might be represented by either of these symbolizations. But remember, these are both A group elements. This is... What was I showing you? Yeah, but beryllium, magnesium, calcium, strontium, barium, so on, so on. Halogens, right? Halogens. 7A, fluorine, chlorine, bromine, iodine. Acetine, probably not going to use it so much. It doesn't really even behave like the other halogens all that much, even though it's in the same group. That's because it's so far down and it's right next to the metalloid staircase. We usually don't do problems that involve acetine. And then the noble gases, or the rare gases, right? 8A, all the way over here, right? The ones that we deal with the most are helium, neon, argon, krypton, and xenon.